Homework 3, which is a SPICE based homework. It's due Friday, October 16 in the afternoon, and it really relies on the rectifier, which we are going to explain very soon, the rectifier circuit, but at least you can start to build the netlist. And also SQ5 will be on Monday, October 12, and it will be up to today's lecture, يعني up to lecture 14, including Zener. Okay, including the
Good morning, Professor.
Good morning, Nidal. Okay.
Lecture 1 يعني من بعد الapproximation.
من 11 لما أخذنا small signal up to the Zener.
Okay, thank you.
You're welcome. So it will be on Zener and small signal analysis. Okay. Okay. So let us continue explaining the Zener diode, which we took last time. The Zener diode, the difference between it and between the regular diode is that we don't have a small signal or a large signal. يعني it is one model only that we will study the Zener in, and its task, we're studying it in large signal, and its task is to really balance the load or make the signal look very similar to DC. So نحن درسنا إنه عندنا Zener diode. It has this symbol. The Zener diode has plus minus VZ, and this is IZ. And we said that the model of the Zener diode is that VZ is equal to VZ0 plus RZ times IZ. Okay, and we also said last time that the Zener can be used as a regulator, as a shunt regulator, and that it can be used to serve two purposes. One purpose is line regulation. هلا بنرسمها بنفهم شو يعني line regulation, and the second purpose is to do load regulation. Okay, so load regulation. هلا by line نحن بنقصد the signal that is coming. So if my VS has fluctuation, if my supply or the source has a fluctuation, okay, fluctuates, I will regulate the signal with respect, minimize delta VO. The objective of it is to minimize delta V output على delta VS يلي هو source signal. Okay. In terms of load regulation, if my signal or load absorbs variable current, okay, يعني إذا اللود بيعمل fluctuation, كمان objective is that we have delta VO على delta IL to be minimized using Zener diode. Okay, so هيدي is a quantity that we measure in millivolts per milliamps, and the top one is a quantity which we measure as millivolts per volt. Typically, لأنه Zener output is small, has small fluctuation compared to the supply signal fluctuation. Okay.
Sorry, Professor.
Yes. Yes, Nidal.
our line بالred هو supply source.
Supply or source fluctuation.
Okay.
Supply or source fluctuation.
Thank you.
You're welcome. Okay. So let us then see how we put it as a shunt. And we said last time, this means that, for example, if I have my VS as function of time t has a large variation independent of the shape of the signal, it fluctuates between VS min and VS max, then we expect that the output across the Zener, وهلا نرسم الcircuit, to have much smaller, the same period, but much smaller fluctuation with time. يعني we want it to be approximately across the zener to be a DC output. لما الدلتا في او على دلتا في اس تكون small, okay, then you will get roughly a DC output. And ideally, therefore, ideally we want delta VO over delta VS and delta VO over delta I load to be very small. Okay, this is the objective of the Zener. So when we placed it in shunt in parallel with the load, the way we placed it, حطينا إن عندنا ال VS. Last time the supply has a certain resistor RS, and then it is supposed to be feeding a certain load, and this load in order to regulate إذا هيدي هون عندي plus minus VO, in order to regulate the fluctuations of the output voltage, I will place here, okay, a Zener diode across or parallel to the load and shunt or in parallel. Okay, so practically speaking, this current here is I Zener, and this current here is I load. And as we explained last time, the Zener operates over a very small voltage range. يعني إذا بدي أعمل plot لل VD versus ID for the Zener, it is going to operate around minus VZ, يعني the Zener around VZ, but it will allow me to operate over a range of current اللي هو حيكون minus IZK all the way up to IZ max. يعني الزينر دايود فيها تعمل fluctuation بالcurrent in order to maintain a relatively fixed voltage across it. Okay? حدا عنده سؤال لحد هلا up till now؟ This is a review of what we explained last time. So now we are going to explain how we derive those quantities. How am I going to study for this circuit those two quantities? Okay, so let us look at the derivation of these two parameters in the context of this circuit. So the first thing that we do is we are going to replace the Zener diode by its model in the breakdown region. Okay. وشو هو الموديل اللي اعطيناها اياه بالبريكداون region? What was the model for the Zener diode? شو كان voltage source, voltage drop? What was the model that we derived? Was it linear? Was it non-linear?
يس بروفيسور قلنا فينا نعملها لينير وبس ناخذ الانترسكشن مع ال نعمل في دي زيرو.
So عملنا لها موديل اللي هو linear. So هاي RS هون وهيدا اللود حنعتبر اللود عم يسحب I load. Okay, اللي هي IL. Okay. And now, all of a sudden, I need to replace the Zener diode with its model. Since it is linear with an intersection, when an equation, we modeled it by this form. Okay, so the model of the Zener diode, this is the model of the Zener diode. So, does this mean that I can model the Zener diode? Let's see. إذا من هون لهون هو VZ والcurrent اللي قاطع فيها هو IZ، يعني أنا بين VZ and this node, between those two nodes, I can really place a voltage source VZ0 صح and a small resistor RZ. Okay, so let us look at this equation here. Let us look at this equation here, and is this satisfied with this circuit here? Does this tell me that the VZ between those two nodes is equal, the voltage between those two nodes, VZ, is equal to VZ0 plus RZ times IZ?
Yes, it is true.
Okay, so if we look at it this way, okay, so this is VZ here, so it is equal to VZ0 plus RZ IZ. حدا ما شايف هالشيء? Anybody did not notice this? Okay, so then I can replace the diode that is here, هون بالgreen. I can draw in its place VZ0, okay, and RZ. هيدا الموديل يلي حنعمل له substitution فيه للدايود. Okay, so anytime we see a Zener diode, we can replace it by its model. Okay, طيب great. Okay, so let us see now in what follows. We are going to do a theoretical derivation for the two sensitivity parameters اللي حكينا عنهم هون. Okay, and then we will take an example. So what does the theoretical derivation tell me? To make this theoretical derivation simpler, what we do is we take this circuit which has a voltage source and a resistor and another voltage source and a resistor, as well as the load current source. We are going now to make the circuit all current source. يعني احنا نعمل النورتون equivalent لكل component. So أول branch عنا إياه هو VS RS. Okay, so this is VS RS. كيف أعمل له الإكوفالنت ل VS RS؟ إذا عندي voltage source وريزستور شو بيصير الإكوفالنت branch لإله؟
الاي بتصير في اس على ار اس
اوكي سو هيدي ار اس ان بارلل وهيدي في اس على ار اس.
بتصير في اس ان
وبننتبه انه الارو اللي طالع طلوع للكرنت هو مثل البوزيتيف ساين. اوكي طيب هيدا اول part of the branch. The second part of the branch that I am going to look at is this VZ0, sorry, is this VZ0 and plus RZ مع الار زي in parallel. So هيدا البرانش هلا اذا بدي اجي اعمل له انا equivalent model, I'm going to make it a current source and a resistor, and again I will have another current source, okay, and parallel with a resistor. شو الفاليو لهيدا الريزستور؟ هيدي ار زي هون حتصير ار زي هون، اوكي، وهيدا في زد 0 حيصير عندي هو في زد 0 على
ار زد
اوكي. طيب شو بقي عندنا هلا؟ بقي عندي اللود كرنت. هون انا كنت قايله انه هيدي هي الاوتبوت voltage which I'm interested in, so I have the load current, it will remain the same وهيدي plus minus هيدي. Okay, so this is my I load. Okay, طيب great. Now we are going to analyze this circuit. Our objective is to write VO as some function of VS I load طبعا VZ0, so that I can derive the quantities مثل ما بنعمل derivative delta VO على delta VS and delta VO على delta IL. Okay, هيدا my objective. I'm going to use circuit number 2 to do this derivation. So هنستعمل circuit B and KCL in B. How can I solve for VO? I'm going to rely on KCL, and how can I find VO? يلا هات لنفكر كيف فينا نطلع VO شو بتساوي؟
A way to do it, no, we can combine the two current sources and the two resistors ونرجع نجيب ال 7 equivalent للcombination.
Okay, we can do that. Let us think قبل ما نكتب KVL in circuit B. Okay, so in circuit B, if I combine all the currents into one current source, شو بصيروا كل ال currents into one current source? VS على RS plus VZ0 على RZ minus IL, right? لأنه IL رايحة بعكسهم صح؟ And
Yes,
then here what do I have? RS parallel لمين؟ RZ, right? طيب, where is VO? Where is VO? VO is across those two parallel resistors, right? So do I know what is VO?
simply RI ولا
R times I. Okay. هلا we could have chosen يعني هيك هلا شفتوها how it looks like. But we could have said that VO is the voltage that is flowing into the resistors. I have effective resistance RS parallel RZ. وكنا أخذنا total current that is flowing هو VS على RS plus VZ0 على RZ minus I dot. So therefore I can write VO to be equal to RS parallel RZ هي RS times RZ over RS plus RZ, right? This is the effective parallel, times VS over RS plus VZ0 على RZ minus I naught. Okay, now I have this quantity. I'm going to expand it into different terms. أول term حيكون فيه VS على RS و RS بيكنسلوا من النيوميريتور والدينومينيتور هون. So حتصير VS times RZ على RS plus RZ. اوكي, هيدا أول product plus VZ0 على RZ و RZ حيكنسلوا if I expand. So VZ0 times RS على RS plus RZ minus IL times RS times RZ على هيدي اللي هي البارلل. حنرجع نكتبها parallel لأنه أهون لنا to continue writing it this way. Okay. Now that I have this expression, I really have VO as function of each one of VS and IL and طبعا VZ0. VZ0 is a constant. So let us define what these terms mean for me. This term has the dependence on VS. Okay. So this is shows the dependency of VS. يعني إذا VS فيها fluctuation, VO will fluctuate proportional to this ratio. This term has dependence on IL. قديش اللود حيغير the amount of current that it is going to withdraw. And this term is the desired because we want really to have the diode regulate. يعني I want it to be proportional to VZ0. So this is what I am forcing on the circuit. So if we want now to calculate the quantity, okay, if we want to calculate now the quantity, delta VO على delta VS is equal to what? What is this quantity? How can we find it? From the equation that we have, from equation star, okay, who can find from star the delta VO على delta VS? If I have y equal ax plus b, and I want to find delta y over delta x, or I want to find dy by dx, can I find this from a linear equation?
It's the slope.
It's the slope, so it's a derivative, right? So A. So نحن هون إذا بيطلعها بالنسبة ل VS, okay, let us color it differently. هيدي ال VS وهيدي ال VO. So del VO by del VS is equal to what?
RZ على RS plus RZ.
Exactly. So it is RZ over RS plus RZ. So this is the first quantity that we derive, meaning if I'm putting the diode in shunt with a source that fluctuates, this is the amount of or the sensitivity of the signal. Excellent. But tiny quantity that we want to derive is really del VO by del IL. Okay, is equal to what? And for this, we are going to look back at the linear equation. هيدي IL home. I want to find the derivative with respect to IL. And in a similar fashion, it is a linear system, so that the derivative بيعطيني coefficient اللي هو minus RS parallel RZ. okay, and it is going to be negatively correlated with it. Okay, so this is the second quantity that we are interested in. Okay, حدا عنده question لحد هون؟ Is it clear for everybody? Okay, so we started with the diode circuit. We placed the diode model. We converted the circuit to become current sources and resistors. We found the relation between VO and the parameters that can fluctuate, the parameters of the circuit, and then we found the sensitivities of VO with respect to the line or the supply, and we found the sensitivity of VO with respect to the load, and now we can really see كيف عم يعمل Zener load regulation and line regulation. Are these quantities small or large? RZ is typically of the order of a few ohms, يعني مثلا 10 to 20 ohms, okay, or a few ohms, okay, whereas R is in the kilo ohm. So those two quantities are typically small because RZ is small. Okay, so those two quantities are small because RZ is small. Okay, so this is what we conclude, therefore it is doing good regulation. Okay, is this clear? حدا عنده سؤال؟ Okay. طيب.
بروفيسور سوري بس دلتا في 0 على دلتا في اس كرمال الفلكشويشن.
هيدي كرمال اللي بنقيس فيها هلا حناخد example line fluctuation. Okay, so this is the line regulation. Okay, and the other one is for the load regulation, to measure how much regulation I am imposing on my load. Okay, طيب great. Yeah. هلا ناخد example. يعني هيدي what matters here for us to know is that RZ is typically much smaller than RS. So let us now take an example along this line. Okay, so now we will see what is given to us. Yes. Okay, so given a 6.8 Zener diode has VZ equal to 6.8 at IZ equal to 5 milliamps. Okay, and given that RZ is 20 ohms and IZK is equal to 0.2 milliamps. يعني already شرح لي عطانا بالcircuit, he gave us some information about the operation of the diode. شرح لنا إنه ال IZK هي 0.2 milliamps. شرح لنا إنه at the point when the voltage is طبعا هيدي negative بس إحنا ما بقى نستعمل النيجاتيف minus 6.8 volts. The current is minus 5 milliamps. Okay, and he told me that the slope اللي بنطلع فيه ال RZ, okay, or 1 over the slope, that RZ equal 1 over the slope, and its value is equal to 20 ohms. Okay, so automatically I know that I can replace the diode. Okay, so I can replace the diode by a voltage source and a resistor, but I have to see what is missing. Also, given that this diode is operating as a regulator, okay, across a certain node, okay, so I have here plus minus VO, and I'm going to plug in here a load, okay, to regulate it, and it is being fed by a voltage source V plus, and this voltage source V plus is equal to 10 volts. So we will look at the first question that they are asking us. So the first question that is being asked is find the output VO, okay, when with no load, and I did not connect anything across my circuit, and V plus equal to 10 volt. أنا أعطيت 10 volts، ما في fluctuation وما في load. He wants me to find V out. Okay? طيب, in order to find V out, first I have to plug in the diode. Okay, so هيدي عندنا resistor here. It is given to be equal to 0.5 kilo ohms. So here I have 0.5 kilo ohm. And in this problem here, I have this is 10 volts. Okay, and then this is V out from here to ground. And in between V out, I have the Zener diode, and I don't have any load. So the first thing that we're going to do is we are going to replace the diode by VZ0 and RZ. Okay, now RZ I know is 20 ohms. VZ0, do I know what it is? Was it given to me, VZ0? VZ0 is not in the given. How can I find VZ0?
What's the equation of the line?
KVL will not tell me. What would it tell me if I don't know
بروفيسور
VZ0?
معنا كل شيء الا الفي زد زيرو، بنجيبها وبنرجع بنعمل
منين
كالكوليشن
بتطلع
للفي زيرو.
VZ0 من أي relation بنحل from the characteristics of
بس
the Zener diode, صح؟
بس ما احنا بدنا الفي زيرو تبع
from the
Zener
Zener diode. ايه بس sorry. From the Zener diode characteristics ما هو عاطيني نقاط، صح؟ Let us see what he gave me. If I want to draw a line or build a line, شو بحتاج أنا؟ بحتاج ل point. He told me that this point and he gave me the slope, صح? And we know that VZ at any point P is equal to VZ0 plus RZ times IZ, صح? So I'm going to plug in the information that he gave me here and the RZ from the diode characteristics. على طول بنطلع الفيزا، حنطلع الفيزا 0 بهالحالة لأنه عطاني a point and a slope or the inverse of the slope. Okay, so he told me that this is 6.8 is equal to VZ0 plus 20 times 5.8 plus 5 milliamp, يعني 5 ضرب 10 to the minus 3. Okay, from this I can find that VZ0 is equal to تطلع معنا 6.7 volts. Okay, okay, so now I have VZ0, I have RZ, I can solve for IZ and from the circuit conditioning, right? هلا نعمل KVL. Okay, so the first step was to find VZ0, and then the second step in this problem is to go ahead and say 10 volts is equal to 0.5 times 10 to the 3 times IZ plus VZ0 اللي هي 6.7 volts plus RZ اللي هي 20 times IZ. Is this clear now? Okay.
بروفيسور بس سؤال صغير.
Go ahead.
سوري. في زيرو مش هي الاكروس ذا زينر دايود؟
V out, yes.
انا اوكي مش هي ذات الفي للزينر دايود في زد يعني؟
I might be operating. هلا بنشوف ال VO شو بتطلع 6.83. I might be operating at a slightly different point اللي هي I can be operating here.
اوكي كرمال هيك بدها calculation.
Exactly. So أول شيء بدنا نعمله بدي أعرف الموديل لهيدي الدايود. لأعرف للموديل بدي أعرف لل VZ0 وبدي أعرف لل RZ. When I put it with its model اللي هي it's going to move on this line its solution point. يعني بحط لها الموديل لصير أعرف وين on this line I am. And now based on the supply voltage and the resistor and the interaction with the diode model, I will be able to solve for my new operating point and find my new operating voltage across the diode. لأنه هي الدايود حتمشي على هيدا اللاين. Okay. And we don't know where exactly on this line it is. It will be in the vicinity of VZ, but not exactly at it. Is this clear?
Okay, thank you. Yes,
Okay, great. طيب, so هلا هيك بنحل ال IZ. So therefore IZ is equal to, تطلع معنا ال IZ بتساوي 6.835 milliamp. Okay, and this value is greater than IZK, so my assumption is correct. يعني أنا موجودة بال I am in the breakdown region. Okay. لأنه لو طلعت أصغر منها بكون أنا مش بالبريك داون region. Okay. And if we look here back at 6.35, it is here. So this is my operating point. عطتني current 6.35 milliamps. وعطتني voltage هلا بنشوف إنه بيطلع 6.83 in absolute value يعني. Okay. هذا ال current in absolute value. Okay. So if we use this IZ, now we can say that VO is really equal to VZ0 plus RZ times IZ, and this value is going to be equal to 6.7 plus 20 times 6.35 10 to the minus 3 اللي بيطلع عنا 6.83 volts كabsolute value V. Okay, so therefore we solve for it in the context of being subject to this specific supply and circuit. Okay, clear? So هلا لكينا we know how to solve for the Zener voltage when we have no load and we do not have any fluctuations in the supply. Okay, هلا part B, in part B, they are going to ask us now to introduce some fluctuation. So in part B, they are asking us to find, okay, the change in VO. قديش ال VO حيتغير بعدنا ما في عنا load for plus or minus 1 volt change in V plus. يعني إذا السبلاي اللي عندي إياه fluctuates, okay, how is VO going to change? I have two options. يا اما بروح بقول بلس اور ماينس 1 يعني الفي او رح بيصير 10 و 11 و 9. اوكي، يا اما I can go back to the previous equation and maybe since the circuit is the same أنا عندي supply وعنده resistor RS وعندي diode with no load around it. Okay, so I can use probably the equation del VO by del VS or V plus. Okay, so we are going to opt to use del VO by del VS. Okay, del VO by del V plus بهالحالة هي حسب ما شفنا قبل للسيميلر سيركت هي RZ على RS plus RZ يلي حتطلع بتساوي 20 على 500 plus 20 which is equal in this case to 38.5. This is the 0.385, sorry. And if we خلينا بس احط لكم final answer حتى ما اغلطكم بالارقام. And if we want to find del VO شو حيكون بيساوي هو plus or minus 1 volt صح times 20 على 520 اللي بتطلع بتساوي plus or minus 38.5 millivolts. Did you all know how we found this? Is this clear for all of us? هيدي عملناها بالجرين هون، هيك حاجة أعملها بالجرين هون. هيدي ال quantity اللي هون. We are clear how we get it, right? And all we did here is really multiply this by del V plus. حدا عنده سؤال عن هذا ال question؟ Okay, so we reuse the equation and we enter the fluctuation in place of the line or supply. Okay? طيب. Great. هلا. What are they going to ask us next about? هلا بده يدخلوا لنا اللود. We're going to look now how the load is going to affect my analysis. So they are going to ask me find the change in VO, okay, resulting from connecting a load that withdraws or that draws 1 milliamp. طب, let me ask you this question. In the initial case, when I had V plus resistor and then the Zener diode with no load, قد ايه كان اللود عم ياخد هون current؟ شو كان الكرنت اللي عم يسحب؟
6.35
لود. في عندي لود،
ما في
عندي ار انفينيتي صح؟ قد ايه كان الكرنت للار انفينيتي بيساوي؟
زيرو يعني.
زيرو صح؟ So this is equal to 0. Okay? طيب great. So this is equal to 0 and sorry في delay بالسكرين اتفرج. طيب هلا إذا عندنا هلا حطينا لود جديد اوكي وقلنا هلا انه هيدا النيو لود draws a current IL and IL equal 1 milliamp in the second scenario. Okay, can I find some delta IL between two circuits? What is the delta IL between the two conditions?
يعني قبل كان 0 صارت 1.
So this delta IL is 1 milliamp. So can I now use the equation delta VO على delta IL, okay, in order to find the change in VO resulting from a connecting the load that draws 1 milliamp, given that before it was 0 and now I know it is 1 milliamp. يعني بعرف أنا قديش الدلتا بالنسبة لوين؟ This would be the delta. I would be calculating delta VO with respect to what condition? With respect to the no load condition. صح؟ طب هيدي الدلتا VO by delta IL نحن طلعناها انها بتساوي minus RZ parallel ل R, which if I plug them in this tells me that delta VO حتكون بتساوي minus 1 times 1 milli يعني 1 10 to the minus 3 times 20 parallel ل 500 اللي هن resistors, وهيدي بتعطيني انه delta VO is equal to minus 20 millivolt. And this delta VO, okay, is with respect to the no load condition. يعني VO no load قد ايه طلعت معنا من شوي؟ VO no load كانت 6.83 volts. Okay, now I can find the new VO as VO old plus delta VO. Okay, so I can assume that the delta in the current هي 1 milliamp. I can find the delta in VO, بس هيدي حتكون الدلتا بالنسبة لل no load condition. Is this clear? وإلا بدي أحط current source 1 milliamp, بدي حل السيركت, and when I solve for the circuit I have now to take VO2 minus VO1 based on the previous condition. Okay? Clear? حدا عنده سؤال؟
بروفيسور ياس بس سؤال
إيه.
صغير،
تمام.
معقول يكون الديفرنس هالقد صغير minus 20 ملي فولت هي لأن امبيرال
ليش؟ What is RZ
لأن
parallel
امبيرال
R؟ حيطلع ال effective resistance أصغر من smallest value صح؟ Because RZ is very small and much smaller than R, then the fluctuations are going to be small. And this is why this acts as a voltage regulator. بالنسبة لو اللود سحب current تغير سحبه للcurrent بضله maintaining a fixed voltage as if I'm supplying a DC supply. Okay? يعني ما بتضعف السيجنال. Okay? Clear?
Yes, thank you.
Okay, excellent. طيب هلا آخر سؤال شوي more convoluted. So in this last question, they are asking us to find the minimum. What is the minimum value of R load for which the diode will still operate in the breakdown region. يعني أنا I can continue regulation as long as I maintain operating in the breakdown region. وتحديدا الكونديشن اللي بدنا إياها هي إنه IZ تكون in absolute value أكبر من IZK. هلا نزلت عنها ببطل الكونديشنز hold وبطل أقدر أعمل regulation. And in this problem they are telling us that V plus is still fluctuating. يعني بعد 10 plus or minus 1 volt. In this scenario, I have here 0.5K. I have the Zener diode. Okay, so I have the Zener diode. And I have a load across the Zener diode, which is going to have the value RL. And I need to find what is the minimum value of RL for which the diode will still operate in the breakdown region. خلينا بالأول ناخد نقطة واحدة. Okay, ونشوف شو ال RL value and then study the other fluctuation conditions for V plus and see how we derive the minimum among. So, حدا عنده سؤال what we mean by the question؟ بدنا نلاقي ال RL بشكل إنه تضل ال IZ greater than IZK. So let us think of it. So the first thing is I push it. I say at the edge of breakdown, okay, I have IZ is equal to IZK اللي هو عطانا إياها in the beginning of the problem, which is 0.2 milliamps. Okay, now if I want to replace the diode by its model حنجي نحط محل الدايود هون. Instead of the diode we are going to place here VZ0 اللي هي 6.7 and RZ. هيدي 6.7 and this is RZ. Okay. طيب, so how do I solve? What is IZ in general? Okay. So IZ is equal to كيف طلع ال IZ؟ عفوا عطيني IZ شو بتساوي هون. قلنا خلينا نخلي IZ شو بتساوي. So what do I need? How can I solve for this circuit? What is VZ at this point? شو بيساوي ال VZ؟ Right? Okay, مظبوطة هيدي relation بقدر أنا أستعملها؟
Yes, Professor.
Okay.
Yes.
So let us assume since IZ is approximately IZK, since this is approximately IZK, سمح لحاله يعتبر إنه هيدي ال quantity very small لأنه 0.2 ملي times 20 ohm is very small. So سمح لنا لحتى نعمل simplifying للproblem نقول إنه VZ is approximately 6.7 volts. Okay, so in here we took this approximation. Okay, طيب great. In this case or in this scenario, can I calculate what is the current flowing in this resistor R? What is IR under this condition?
0.2 plus 6.7
So
over
let
RL.
us start with the case when V plus equal to 9 as a starter. IR شو بتطلع بتساوي؟ V plus minus VZ على R صح؟ اللي هي فينا نطلعها the other way بس نحن ما عندنا RL أنا بدي أطلعها in a way that I can find it as a known number صح؟ What is IR؟ 9 minus 6.7 على 0.5 صح؟ تطلع بتعطيني هيدي 4.6 milliamps. Okay, so now I have IR, I have VZ. Can I find the value for our load that is going to push my operation to the edge? يعني أنا معي إنه IR plus I Zener or IR is equal to I Zener plus I load, right? This means that 4.6 milliamp is equal to 0.2 milliamps plus what? Plus I load. What is I load? 6.7 over R load, right? So from this, I can solve for what? I can say now that R load under this condition is equal to what? بيطلع معنا إذا بنحلل له 1.8 kilo ohm. This was solved for at what value? At V plus equal to 9 volts. هلا حارجع عيدها. Okay? So, great. إذا بدي أجي أنا طلع a general equation. So this is a method where we can find the general equation, a solution for RL at a given voltage. Let us draw the circuit again and let me put the diode here, okay? And let me put the R load here. And let me say that this is V plus, this is 0.5K, and this voltage here is VZ. And my objective is to have IZ greater than IZK, right? طيب شو بتساوي IZ؟ ما هي IZ which is going down like this is really equal to IR minus I load, right? And IR is equal to V plus minus V Zener على 0.5, okay, مظبوط, minus I load اللي هي V Zener على RL, okay? If I allow myself to assume that V Zener is approximately VZ0, okay, لأنه أنا in the vicinity of ICK, okay, in the vicinity of IZK, near IZK, because I am near IZK, okay, because I am near IZK, ساعتها كيف بتكون relation? Let us understand the relation بين IZ. What is the relation between IZ and RL? كلمة, I'm going to ask you a question. If I look at this equation here, and I'm going to ask you this question. If RL increases, شو بصير بهيدي الكوانتيتي؟ minus أو let us look at it this way. VZ على RL شو بصير فيها؟ decrease.
بس هي
يعني
negative.
ال IZ بهي الإيكويشن شو بصير فيها بس هي negative؟ It is going to increase. طيب و if RL decrease يعني VZ على RL is going to increase, صح؟ يعني what is going to happen to IZ؟ هتصغر، صح؟ مظبوط؟ So this relation is telling me كل ما صغر ال RL شو حيصير بال IZ؟ هتصغر. طيب أنا إذا جيت قلت لكم إنه for a certain voltage condition, okay, for a certain voltage condition لما V plus equal 9, IZ equal IZK given. هيدي next time نرجع نعيدها. when RL is equal ل 1.8 كيلو أوم. وحطيت لكم سكيل وفرجيتكم هاي 1.8 كيلو أوم وهيدي ال RL. At this point, at here, IZ equals ل IZK. Okay? طيب great. كل ما كبر ال RL حال IZ تكبر، وكل ما صغر ال RL شو حيصير بال IZ؟ حتصغر. وين ال forbidden region عندي أنا؟ بقدر أصغر عن ال IZK to stay in breakdown. ما بدي أنزل على مين؟ عن ال IZK، صح؟ right؟ لضلني بالبريك داون مش من مصلحتي بقى أصغر ال RL لأن ال IZ حتصغر. فإذا ال forbidden region أوكي هو any resistance where RL أصغر من 1.8 كيلو أوم. أوكي؟ Is this relation here clear? طيب next time we will repeat from here. I think this is a little bit overwhelming. And go back to see now how I incorporate the fluctuation of V plus. Okay? Yeah. Thank you. And we will continue from this point. We will repeat a little bit and we will continue from this point next time. Thanks.